Yeah, what's up, good people? Good people, you're welcome back to a session with Edu Ada. Thank you. Quickly today, we are going to division of binary numbers. Division of binary numbers. In the previous videos, we spoke of conversion of binary numbers to decimal or denary or base 10. Then we also spoke of I think I taught the division, the conversion to base 2, which is binary. So now quickly we'll be talking about division of binary numbers. We all know when you have binary numbers, it involves 0 and 1. If you now have a question that involves division of binary numbers, there are various ways you can go about it. The first one, which I think or I will want to say is the old approach, is you have to convert to base 10, then you now bring it back to where you are going to. But let me illustrate with this example. We are going to be using a long division approach, which we all know, which I expect every student to know because it's a basic class concept. So let me illustrate with an example first. If you have this, for example, yes, divide this by long division method, you have 624. 624, of course, divided by, let's say we have 8. You remember the long division approach? You check 8 in 6 first. You have to check 8. How many times you have 8 in 6? That's not possible. 8 cannot divide 6. So you combine these two together. If you like, you can write 0, since 8 cannot divide that. So you write 0 there. 8 times 0. 8 times 0 will be 0. Then you subtract. At subtracting, you have 6 down. 8 cannot go in 6 again. What do? You bring down these 2. Bringing down these 2, you now have 62. So 8 in 62, that should be, let me pick up my calculator. 8 in 62, that should be 7. So if you have 7, then you multiply again, right? 8 times 7, you have 56. Subtract 56 from this. What do you have left? 6 minus 2 minus 6, not possible. Borrow from here. This one becomes 5. This one becomes 12. So once one becomes 12, 12 minus 6, you have 6, isn't it? Then what do? You bring down this 4. Since 8 cannot divide 6 again, you bring down 4. Then 8 in 64, that will be 8. 8 times 8 is 64. Subtract 64 from 64, you have 0. So your answer becomes 78. That is approach for long division method, isn't it? So the same approach we are going to be using to solve question 1, division of binary numbers. Even those ones that have to deal with base 3 and other bases, we use long division approach. So let's go together. Question 1. We have this. We have this. How many? 1, 2, 3, 4, 5. 2, 3, 4, 5, 0, 0. Then you are dividing 1 and 0, which is 1 and 0. So what do we have? 10 in 1, of course, is not possible. Check 10 in 11. 10 in 11 is 1. Then you multiply. 1 times 10, you have this. then you subtract, right? When you subtract, what do you have? 1 minus 0, it is 1. 1 minus 1 is nothing. 10 cannot go in 1, right? Bring down this. Bring down this 1. 10 in 11 again, it is 1. 10 times 1, you have 10. Subtract again. 1 minus 0 is 1. 1 minus 1 is nothing, which is 0. You don't need it. If you like, you can write it. Then 10 cannot divide this 1. Bring down this 1 again. Bring down the next one. 10 in 1. 10 in 11. That will be 1. 10 will go there 1 time. Then 10 times 1. That is 10. We are still in the business of subtracting again. This will give us 1. This one will give us 0. Bring down this 1 again. You have 11. 10 in 11. So you have 1. 10 times 1. 10. Subtract. This is 1. Bring down this 0. 10 in 10. You have 1. 10 times 10. 10 times 1 rather. You have 10. By the time you subtract, you have 0. Bring down this 0. You have 0 here. Then 10 in 0, of course. 10 will go in 0 is 0 times. So 10 times 0, you have 0, you have another 0. Subtract them, you are going to be having 2 zeros. So this confirms our answer. That is our answer. It's just following the long division approach. Are you getting this? Very good. I expect that. So we go now. Let's solve question 2. Let's solve question 2. Example 2. What do we have there? We were told to convert 0.5 to binary. It's in base 10. Yeah, we can solve this question 2 ways. We can go 2 ways. So the question will now be, how do we go? When we treated conversion of decimals to fraction, which I did in one of the videos, I have 0.5. 0.5 over 5. What's the place value of 5 here? It is tenths. So that means we have 5. We have 5 upon 10. Then everything is in base 10. And we have to re-express in base what? In base 2. Now, I will be solving this question in 2 methods and we arrive at the same answer. Let me go by the method you will likely know. If you have this in base 10, I have to change to base 2. You're supposed to use the tabular method, which I've done in the previous video. But because we're having a fraction to deal with, what do? We first change the numerator to base 2. Then we change the denominator to base 2. Then we divide our answers. Yeah. So let's go. If you have 5, let's do 5 in base 2. So let's convert 5 to base 2. 2 in 5, that is 2. Remainder 1. 2 in 2, 1. Remainder 0. Isn't it? Then you have 2 in 1. 2 in 1 is 0. Remainder 1. 2 in 1 is 0. Remainder 1. So all in all, let the arrow show up. That means you have 5. 5 in base 10 will be equal to 101 in base 2. Let's do for 10. This is 10. 2 in 10, 5. Remain the 0. 2 in 5. Bring 2 again. 2 in 5 is 2. Remain the 1. Then go again. 2 in 2, 1. Remain the 0. Then you go 2 in 1 with 0. Remain the 1. Then indicate your arrow up. Movement is up. So 10 in base 10 will be equals to what? 1, 0, 1, 0. Can you see what we have? So we are going to be having 5 to be 101, base 10 to base 2, then 10 in base 10 to base 2 will be 1010. Now don't forget our question is 5 upon 10, and that will be equal to 101 upon 1010. So we are back to what? Division in binary numbers. So what do? We have 10 divided by 10. Let's do the division. Let's do division. Let me do that here. So I'm going to be having I will have this one zero one. Then you have 1010 outside. Yes, check it. If you look at this, 1010 is bigger than 101. So it cannot go in 101. What do we do? That means this is not possible. You have 0 points. Just like our normal division. You add 0 here. Am I flowing? Are you flowing with me? Good. So you have, it cannot, 1010 is greater than 101. So you have to, it's not possible. You have 0 points, you add 0 here. Then you check 101 in 101. Of course, they are now equal. That will be 1. Then 101 times 1, that will be 1010. Subtract. You have 0, 0, 0, 0. We as good as done. Therefore, 1 the question was 0.5 in base 2. Therefore 0.5 in base 10 will be equal to 0.1 in base 2. Of course, it's in base 2 already. So you have your answer. Alternatively, you can go this way. Just multiply. Because I change to base 2, you can have 0.5 times 2. 2 times 5. Be noting what I want to do is it's an approach. It's a method that has been developed by a mathematician that has been found to be true. So it's another method you can work with. So 2 times 5 is 10. You have 0. You keep 1. The one you keep, you put your point here, you put it here, you put it in brackets. Do you see this? So here again, you multiply again this number here. 2 times 0 is 0. Do you see this? So what do we have? This is point. Is there any remainder? No remainder. That's 0. So your answer becomes, you follow this trend. The ones you put in bracket are like your remainders. So that's what you write. So you have 0 points. You have starting with 0 points. Then this one that are in bracket, you write them out. 1, 0. And that is equal to this. Are you seeing that? 0.10 is empty at 0.1. They are both in base 2. So thank you for going through this with me. You can go through the videos over and over to capture the idea behind each method. Should in case you have any question to ask me, any clarification, you can always make your comment on the comment section, or you call me on this contact. I have 869470. Thank you. I'll be working on other forms of division in the next video. Thank you. Thank you.